Good morning, boys and girls, ladies and gentlemen, cats and dogs. So today we are going to talk about lesson 3, dealing with ellipses. This equation in the notes looks scary, but luckily it's not too bad. Our Elmos for the day are going to be exactly the same as we've been doing the last 2 days. We're going to be graphing, but this time ellipses. We're going to write equations of ellipses. We're going to have key features of our ellipses. Now, as I said, a lot of information here. We're going to have a center, max or major axis, minor axis. We're going to have vertices. We're going to have covertices. We're going to have something that's called foci, which is plural for focus. We had a focus with a parabola. Now we're going to have multiple foci on our graph. And then we're going to have the big scary equation. Now, this actually looks very similar to our circles. The difference is instead of equaling our radius, we have a number squared underneath the x, number squared underneath the y, and it's equal to 1. It will always be equal to 1. Now, all of these pieces we will talk about as we're doing our example. So I'm going to move my paper down. Problem number 1. Step 1, I'm going to find my start point, my center, just like I found my center for my circle, just like I found my center for my parabola. So I look at this value right here. -2 is going to become a +2. +1 becomes a -1. So I'm going to plot that point, 2, 1. And I'm going to put a point right there. Now, technically, we don't need to graph that point, but it's a good visual to help us out. Now, our second step is we're going to look at this value right here. What we're going to do is take 16 and take the square root of it to give us 4. Now, this 4 is going to tell us how far to travel on the x-axis. So our x-axis, because it's underneath the x, is going to be 4. So I'm going to travel to the right 4. 1, 2, 3, 4. Place a point. I'm going to go to the left 4. 1, 2, 3, 4. Place a point. Similar to what we did with our circles, but instead of going all 4 directions, we're only going to do the square root of 16 left and right. Then I'm going to do the exact same thing with the 25. So I'm going to take the square root of 25, which is obviously 5. And now, because this is with the y, that's going to tell us to go up and down. So I'm going to go up 5. 1, 2, 3, 4, 5 points. Down 5. 1, 2, 3, 4, 5 with a point. And that is going to give us our ellipse. Now, I'm going to attempt to draw my ellipse. My ellipse is basically a circle that is being squished or elongated. So it's going to look very similar to a circle, especially in this example, because our lengths and heights are similar. So all I'm going to do is kind of draw kind of an oval going through our points. Mine looks a little bit more like a circle than an ellipse, but it's the same concept. So it's an ellipse is kind of like an elongated circle, as I mentioned. The last thing we need to do is to find our foci. Our foci, if we look up here, they give me 2 formulas. The easiest thing to do to remember your foci is you're going to take the square root of the difference between these two numbers. So 25 minus 16 equals square root of 9, which is going to equal 3. Now, again, just subtract the 2. I always take the bigger number minus the smaller number so I don't get a negative value. Take the square root of it to give us 3. Now, this value is always going to be on the bigger part. So if we look at our graph, left and right is 4, up and down is 5. So 5 is bigger than 4. So our 3 value is going to be on the bigger. So I'm going to go from our center. I'm going to go up 3, place a point, down 3, place a point. And this is going to be our graph. So things that I'm going to be looking for is these 4 points on the ellipse and our 2 foci. Now, we have to do our key features. Major axis. This is either going to be the x-axis or the y-axis. And very, very easy, it's always going to be the bigger of the two. Again, left and right is 4, up and down is 5. 5 is bigger than 4, so up and down is bigger. So we're going to call the major axis the y-axis. Almost wrote the wrong thing there. So our major axis is the bigger one. So always remember it's the bigger. Vertices. Vertices are always on the major axis. So if I look at this point right here, I'm to the right 2. So I got 2 comma up 1, 2, 3, 4, 5, 6. So 2, 6 is one of my vertices. My other vertice is a lower point, so that's going to be 2, -4. So my vertices are always on the major axis. Covertices are going to be the other 2 points, the minor on the minor axis, or just the other ones. So if I look here, this looks like -2, +1, 1, 2, 3, 4, 5, 6, 1 would be our covertices. So vertices are on the major axis, the bigger axis. Covertices are on the minor axis. Last but not least, our foci, which again are on the major axis, is going to be 2, -2, and 2, 4. I'm going to also wish I gave myself a little bit more space, so that's a little messy, but hopefully you guys can follow along. So again, we'll do a couple of these to get us prepared. Moving on to example number 2. Here again, I'm going to start off by finding my center point, which isn't required in our graph, but it's easy for visualization. The +3 is going to be to the left 3. 1, 2, 3. The +4 is going to be down. 1, 2, 3, 4. Place my point. That is my center point, kind of my reference point. I look at this value to figure out how far left and right I'm going to go. I'm going to take the square root, so I'm going to go to the left 3 and to the right 3. I'll look at the 4 that's underneath the y to tell me to take the square root of 4, which is 2. So I'm going to go up 2 and then down 2. From here, I can draw my ellipse, or at least try in my case. As you can see, it's a little bit more elongated, so that kind of gives you a better vision versus problem number 1. My major axis, left and right, is definitely bigger than up and down. So now our x-axis is our major axis. Our vertices now are going to be left and right because they're on the major axis, the bigger of the two. So this point here is 1, 2, 3, 4, 5, 6. So -6, -4, and 0, -4. Covertices are the smaller of the two, so it'd be the other two. So this point is -3, -2, -3, 1, 2, 3, 4, 5, 6. -6, excuse me. Last but not least, we need to find our foci. Our foci are going to be found by taking the square root of 9 minus 4, always bigger minus the smaller, which gives us square root of 5. Using my fancy math machine, square root of 5 is like 2 point something, I believe. Yep, 2.2. Always on the major axis, so I'm going to go to the left 2.2, to the right 2.2, 1, 2, 2.2. Finding my points for the foci sometimes get a little bit more challenging with our decimals, but I think we'll be okay. So let's look at this one. We are 1, 2, 3, 4, 5.2. So negative 5.2, comma, -4. Other foci is negative 0.8, comma, -4. For assessments, I will definitely give us more room than we currently have on this. I did not plan very well when I typed this out, so just be aware of that. So again, determining on which is the major axis, the key point for finding which ones are vertices, which ones are co-vertices, in the direction the foci are going. It's based on which is bigger. So it's kind of shallow for ellipses. They always care about bigger over quality. So just be careful with that. Bigger is where our foci are going to be. Bigger are going to be where our vertices. Let's see. I think I have couple more examples. Let's just do one more. Let's take a look at number 3, then we'll look at one of the writing the equations. So here again, number 3, I have x plus 2 squared over 36 plus x, error. Let's change this to a y. That will be not the last time we see that error on this, in this unit. So step 1, I got a plus 2, so that tells me I'm going to move to the left 2. -1 moves me up 1. So that's going to be my starting point. Take the square root of 36. That's underneath the x, so that's going to tell me to go to the left. And to the right. Then I'll look at square root of 9, which is 3. So I'm going to go up 3 and down 3. Again, the y tells me it's up and down. X tells me left and right. From here, I get to sketch my ellipse. Did not do a very good job on the right side on that, but you guys get the general idea. And as we talked about on Tuesday, you need to make an effort to make an ellipse. If it's a rectangle or a square or a rhombus, it's going to get marked wrong. Major axis. Obviously, left and right is bigger, so x-axis. Vertices would be the ones left and right. 1, 2, 3, 4, 5, 6, 7, 8. So we go -8, up 1. So -8, 1. 1, 2, 3, 4. 1 would be our vertices. Co-vertices would be the up and down points. So I got -2, up 4, -2, down 2, so -2. Last but not least, we need to figure out our foci. Foci are going to be found by the square root of the difference of the two bottom numbers. So 36 minus 9 equals square root of 27. Using my fancy math machine, I get an answer of 5.2. We don't need to go very far with our decimals just because when we're graphing it, you're not going to notice anyways. So 5.2, on the major axis is x-axis, left and right, so we're going to go 5.2 to the right and 5.2 to the left. From here, we just need to do some calculating to find our location. It's 1, 2, 3, 4, 5, 6, 7.2 in the negative, comma 2. And the other one would be 1, 2, 3.2 on the positive to give us our location for those. And again, there'll be a little bit of rounding on this, and as long as you're close, you'll get credit for those. So this is graphing our ellipse. They're a little bit more challenging. You got to think a little bit more, definitely a lot more than you have to do with the circles. You do have to kind of plot and think about where our values are going to go. Remember, major axis is the bigger axis. Number 2 and 3 was left and right. Up and down will be the y-axis, so the y value is bigger. Writing the equation. So I'm going to do only one of these. I'm going to also forewarn you, my computer software kind of distorts our picture, so make sure you really count where your values are. Now, first thing you should do is try to find the center. To find the center, make sure you calculate. Looks like from here to here gives us a center point right here. Again, I notice 3 to the left, 3 to the right, up 4, down 4, so that is my center. From here, I'm just going to start writing my equation. So I know it's going to be x squared. There's going to be a number on the bottom. I will put a plus sign. Y squared. I know I'm going to put a number on the bottom. Then I'm going to put a 1 here. Now, looking for my x value of my center, I'm going to the left 3. To the left is obviously plus 3. Y, we're going up 3, so that's going to be a minus 3. Next step, probably the easiest thing to do, is calculate the distance from the center point to the side. From here to here is 3 units. We square that to get our value here, just like we square the radius for our circles on Tuesday. Then for the y, we'll do the same thing. We count 1, 2, 3, 4. We square it to get our 16 here. And that gives us our equation. So left and right is 3, up and down is 4. This 3 gives us to the left. This 3 moves us upwards. So this is graphing or writing the equation of our ellipse. So be careful with these. Again, the pictures are distorted sometimes. Be very, very careful with this. So this is graphing our ellipse. Our assignment, which you'll be able to pick up, shows you or has you do all 3 of these shapes: parabolas, circles, and ellipse. Think carefully on each of the properties. I will be back on Thursday, so we can review this a little bit before we go over our final shape. Then Friday, we'll review all of the shapes. Then Monday, we will take a formative assessment. Good luck, everybody, and we'll see you soon.